Okay, so now we're going to continue with part B. Alright, so if you remember, this is the point that we store is when natural log of x equal to phi minus x. We store x as A and y as B. So we can call x and y. Okay? So in this problem, it's a cross-section, which is a square. Right, but do not evaluate. Again, if we look at this one, I have to split this into two regions. Because if I do one region, the curve that we have is not consistent. One is not always in the top, and one is not always at the bottom. So I'm going to split it up. So think about when you do a square, area of a square is s square, right? So in this case, it's going to be the function itself, whatever the function, square. So I'm going to set it off from the x values from 1 to a, which you already store the a value. So the first one is natural log of x, which is natural log of x. Since this is a square, so this is a psi second power per dx. Plus is from a to phi, and the second part, the length, if you can think of that, is the length is phi minus x. But again, the area of the square is psi times psi, so this is phi minus x squared dx. So this one just asking you to set up, have not asking you to solve. So if you can do this, think about this. You will have just this. You have 3 points for this part, okay? 2 points for these two integrand, and another point that you add them to express them as a total. So this is 3 points problem. It's pretty simple. So I want you to go back to your notes and look at cross-section, how you set it up, for a triangle, how you set it up for semicircle, how you set it up for equilateral, and how you set it up for rectangle, how you set it up for square. It's pretty easy for you to get the point if you get the concept, if you have the setup. So for this one, as you can see, if you can set it up, that's simple. And you have 3 points, you don't have to even solve anything. Okay? So since it's a short problem, what we're going to do is that I'll give you a minute, pause this video at this point so you can take notes for part B. And I'm going to clear the page and we will start with C. Alright, so what I would do is I'm going to clear this page and look at C. So C is asking the horizontal line y equal k, divide this region into 2 equal area. So there's a couple ways we can divide. So we can divide vertical or horizontal, either way. But in this case, I would like to split it up into, because it says y equal k, so this tells me the k should be a horizontal line. So it's telling you is it's going to be vertical. So somewhere, I don't know, I'll make it up, that line, y equal k. It could be here or above a little bit or lower a little bit, but that's the line. Write but do not solve. An equation involves one or more integral whose solution give the values of k. So if you can think of this, remember part A, when we find the area of R. So if you can do this, it's from 0, because this is horizontal, so I'm looking at this way. So I'm looking at dy. Okay, so think about part A. The first part, when I did with dA, we solved for x values, we solve for, so let's recall, so e to the y equal x, and for this part we solved and we have negative y plus 5 equal x. So that's the part that we solve for, remember, and then we take right minus left to find the area. So I'm going to use the same thing for part A. From part A, that's what I have. But I'm going to switch around a little bit. I like to write positive number first. I do 5 minus y, which is the same. take away e to the y dy. So over here, because we split this up at certain point to make it equal, so y over here, so think about this. This is a 0. Remember the last time is from 0 to b, which is up here. A and b, but we look for the y value, so from 0 to b. Now, instead of from 0 to b, it's from 0 to k, because that's the line that we're going to split up the region. So how do we find that? Since it says split it up into 2 equal regions, that means the area, half of that, so I'm going to use part A, so it's half of the area in part A, which is 2.986. And I can leave it like this, okay? You can solve it or you can leave it. So you can do this. If you have the integrand, that's 1 point. If you set up the limit from 0 to k, that's another point. And this equation, that's another point. So this problem is a 3 point, which is, again, if we can draw out the picture and understand the question, it's not too bad, okay? So office hours, if you have any question, please see me on Wednesday. I should have office hour on Wednesday and Thursday, okay? All right, pause and copy down the notes and let me know if you have any question tomorrow in class.